All right, so let's do some calculations and pay attention to significant figures. Now, the very first type of calculation that you will do is adding and subtracting. And if you add or subtract, you actually go by the fewest number of digits after the decimal point. So the fewest number, I'll just write DP for digits after the decimal point or decimal places. What do I mean by that? Well, maybe you've got two masses. Maybe you've got 13.8102 grams, and you've got another mass that is maybe, say, 1.2 grams, and you want to add those up. So you're going to sum those two together. The top digit actually has 1, 2, 3, 4 digits after the decimal place. So we say it has 4 decimal places, 4 dp. The bottom one just has a single digit after the decimal place, so it has 1 decimal place. That measurement's only good to 1/10 of a gram. The one above is good to a 10,000th of a gram. And when we add it up, we can actually only go to the worst number of digits after the decimal place. So if you like, we can draw a dotted line down there and say that our final answer is actually only good to that worst measurement. So if the worst one's only good to 1/10 of a gram, right, 1 digit after the decimal, then the final answer is only good to 1 digit after the decimal. So 13.8102 plus 1.2, our calculator would say 15.0102, so I could write 15, and I don't know why I keep switching to eraser mode, 15.0102 of a gram, and essentially I'm not allowed to write anything past this one here, so that means that my final answer would be 15.0 grams. So this has 1 decimal place. Now you might say, well, we just spent all that time talking about significant figures, and of course we can count significant figures here too, and you might want to just very quickly pause this video and count how many are there in 15.0 grams. Okay, and if you unpause it, the answer is there are actually 3 significant figures, because that trailing 0 counts because there is a decimal point in here. So although when we add and subtract we don't pay attention to sig figs, if we do a calculation that involves multiplication or division, we will need significant figures, and so sometimes we will be placing this in another calculation, so we'll have to be able to place the number of significant figures. So let's do multiplying and dividing next. All right, let's multiply a couple of numbers together, shall we? So let's take a number like 13.8 inches and multiply it by, say, 7.083 inches. So maybe we're going to figure out an area or something, right? So we got a length times a breadth. Now I got my calculator right next to me, so I'm going to just type in 13.8, and I'm going to type 7.083, and it's going to give a fairly wicked large number, actually, so 97.7454, and the units should be squared inches. But the question is, am I really allowed to write down all 6 of those digits? And the answer is almost certainly no, you absolutely cannot. And we have to go ahead and count significant figures. So if the digits are all non-zero, it's just a case of counting up how many digits. So why don't you go ahead and try this? So 7.083, how many significant figures is this? Pause the video, write it out. Let's compare notes. Okay, if you're unpaused, then although there are 3 digits that aren't 0, the 4th 0 is counted because it's a captive 0. And if it's a captive 0, then according to the sig fig rules, right, we get to keep it and capture it and use it. And at the end of the day, though, what do we have? We've got 4 sig figs, we got 3 sig figs. How many do we write? And the rule, which I forgot to tell you, right, but you can probably figure out from the last screen, is that you go by the fewest number of significant figures. So if you multiply and divide like 5 or 6 numbers together, whatever's the weakest link, whichever one has the fewest, is how many you can write at the end of the day. So I really can't write any more than 3 significant figures here. So I like to go ahead and I just like to check the first ones there that aren't zeros. So if it was 0.0977, I would ignore the leading zeros, they never count. But I would start at the first digit there, so 977, and I would go ahead and say that 4th 4, so that's lucky, right? We chop it off, and then everything else I just put a line through and just say, they're all going anyway. So we can only keep up to that 3rd significant figure here. And actually this brings us to rounding rules. So the question is, are we allowed to just chop off that 4 and leave it, or do we have to do something different here? And the rules for rounding are typically if we remove a 5 6, 7, 8, or 9. So if we remove one of those as the first digit, then we do what we call round up. So we add 1 to the last remaining digit. So for example, if we had, say, something like 13.8, right, and we rounded it to 2 significant figures, so that would mean that we could keep the first 2, and we could have the third one, though, chopped off. So because we are rounding off an 8, and if it's a 5, 6, 7, 8, or a 9, we round up, then that 3 gets rounded to a 4. So at the end of the day, we'd actually write that as 14. And the second rounding rule, right, is if we remove, so ... because I'm lazy, right, if we remove a 0, a 1, a 2, a 3, or a 4, we basically just leave alone. So we leave alone. So if we had, say, something like 13.84, and we wanted to round it to 3 significant figures, right, we would keep, let me switch colors there. We'd keep the first 3, the 1, the 3, the 8. We'd be rounding off and removing 4. If there were extra digits, right, we would be lopping them off too. But because it's a 4, that means that we actually just leave alone. So it would be 13.8 at the end of the day. And it's generally a good habit to get into to write the number of significant figures to the right of the number. So at the top of this page, right, so we had 97.7454 in our calculator. We said we really can only write that third digit there, and we can ignore the rest. And because it was a 4, we really can just kind of chop it off and remove it. So at the end of the day, we should be writing this as 97.7 squared inches. And I'm just going to go ahead and put it in a rectangle. And oh, I already forgot, right? So you should put that 3SF next to it, just as a reminder that you've done it correctly. So I'll just look at one gotcha, because it turns out that sometimes it is a little more difficult than I made it appear. And you're all smart. You'll be like rolling your eyes and saying, "Oh, I can't believe you told that to us," or oh, that's kind of really cool. So let's have a look at the one example where you can't just chop off and remove, and after that we'll move on to do something really cool like conversions. All right, stay tuned.